Hey guys, and welcome to Coding for Kids. In this video, I am going to be talking about binary code. So first, let's look at the overview of this video. In this video, we are going to be talking about input, process, output models. Then we're going to be talking about what is binary code and patterns we see in binary code. Then we're going to be talking about binary light bulbs and how on means 1 and off means 0. And then we're going to be talking about numbers and binaries and the ASCII. We're going to be looking at an ASCII chart. And then finally, we're going to end with letters in binary. So first, let's look at this input process output model. So what does this mean and how is it important in programming? Well, let's just take a calculator as an example. Our input is 1 and 1. Keyword, I'm saying 1 and 1. And then the process is addition or adding 1 plus 1. And then our output would be 2. So this is what an input process output model is. And it's very important when programming games because this is the process where computers this is the process which a computer goes through. Now, if we look at how does a computer process the input? Well, this is our number system. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So 0 to 9. And then using those simple numbers, we can make complex numbers like 92. These are the base numbers. But in a computer, it's zeros and ones. And I don't mean just for numbers, I mean anything. All the images you see on your computer, all the words you see on your computer, sentences, symbols, everything is made up of zeros and ones. So how is this possible? Well, first, let's look at patterns in binary. So first, let's look at our number system. We have a ones place, a tens place, and a hundreds place. And we could represent this as 1, then 10 to the power of 1, and 10 to the power of 2. But in binary, it's a little bit different. Instead, we have 1, then 2 to the power of 1, and 2 to the power of 2. This is binary, so it's a little bit different than our number system. So if we go here, first let's look at binary light bulbs, because we know the arrangement, I guess, as we saw here, but let's talk about binary light bulbs and how it represents on and off. So 1 equals 2 on. You can think like 1 as positive, I guess. And then 0 would be no, or it would be off. So I also like to think of it, even on and off is a great way, but I like to think of it as 1 equals to yes and 0 equals to no. But in this, we're just going to be focusing on 1 equals to on, 0 equals to off. So right here, I have a little pattern for you guys to solve out. So if I said 0 equals to off and 1 equals to on, we can say that 0, because this is off, 1, this is on, 0, this is off, and then 1, this is on. So it'd be 0, 1, 0, 1. So that's how we figure out a binary string, and binary strings are just a string, like a line of ones and zeros. So now that we know how to represent it, first let's look at, first I want you guys to solve this. Represent 1, 0, 0, 1, 0 by turning the switches off and on. So right here I have a little key, so a green light means on and a black light or just off. If it's just black, it's off. So I'll give you guys some time to think. You guys can pause the video, but let's get on to the answer. So let's look at the answer. So here's how. So first you would, this is on, so that would mean a green light because 1 equals to on. So on and then off because 0, 0, so off, off. Then on again because our string was 1, 0, 0, 1, 0. So it would be on, off, off, on, off. So here's how you do 1, 0, 0, 1, 0. But now represent 1, 1, 0, 1, 1, 0 by turning the switches off and on. So again, here's the little image for reference. You guys can pause the video, can draw it out somewhere, but let's get on to the answer and let's discuss it. So here's how. So I said 110, 110. So it would be on, off. So this is how you represent ones and zeros using lights and on and off switches. So now let's look at numbers in binary. So how would you represent numbers in binary? So first, 0, it would be all 0. And you can kind of think of this as lights. So you wouldn't really turn it on anywhere because you could almost think of it as yes and no, actually. So is there a zeros column? No. So you would just say no for everything. We don't want anything. Zero is just zero everywhere. But 1, we would say yes for the ones column because 1 is in the ones column. That's why it's 1. So once we see a 1, because 1 equals to 1, we would put it under the ones column. So 1 in binary is just 1, 0, 0. So now if we look at more numbers in binary, we can see that 2 would fall under the twos column. So it would be 0, 1, 0. So this is how you represent 2 in binary. And 4 in binary, it would be a yes under the fours column. So it would be 100 in binary. And then 3 in binary, well, how would you do that? Because there's no threes column. Well, for that, it's just a little different. You would just add, I guess. You would do some simple addition. So you would add, 2 plus 1 equals 3. So we'd say yes and yes. We wouldn't mark a 4 because that would equal to 7. And we're not on 7, we're on 3. So 2 plus 1 equals to 3. So we would put 1 here and then a 1 here. So it would be 1, 1, 0. So these are numbers in binary. But now let's look at this ASCII chart. And if you guys don't know what ASCII stands for, it's just American Standard Code for Information Interchange. And that's a big mouthful, so that's why we say ASCII. But what ASCII is in computers, we have so many different types of computers. We have Chromebooks, we have Dell computers, we have MacBooks, we have so many. So each company, I guess, has their own binary code. Binary, like their own way of doing binary. The ASCII is the standard. It's very standard. Nowadays all computers follow ASCII. So it's really important to know these, at least become familiar. So here I have a little chart. So it says here capital A, and right now capital A and lowercase a are different. So if I say A, just know it's uppercase A. So uppercase A would be 65, but we're representing binary as strings 0, 1, 0, 1, like that. So how would it be 65? Well, if we go to the next slide, we can see that A equals 65 right here in parentheses. You would represent it. So binary is in powers of 2. So for example, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6. So you'd keep on going on like that. So that's how I came to 64, because 2 to the power of 3 is 8, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6. So now that I'm here, it's almost like how we did it for the number 3. You need to do some simple addition. So we would put a 1 under the 64 column, and then we would put a 1 under the ones column, because 64 plus 1 equals 65. So now that we know A in binary, what would B represent in binary? So you guys can pause the video, but let's discuss the answer right now. So B is 66 in ASCII. So you would put a 1 under the twos column and then a 1 under the 64 column, because 64 plus 2 equals 66. So now, how would you represent C in binary? So you guys can pause the video, but let's discuss. So C is 67 in binary, or in ASCII. So now we can see that it's almost like the number 3, because we can see there's no, of course we need to put a 1 under the 64 column, but that leaves us with 3. So we would just put a 1 under the 2's column and a 1 under the 1's column. So 64 plus 2 plus 1 equals 67. So this is how you do alphabets in binary, and I hope this makes sense to you guys. So now let's review. So an input process output model, we took a calculator as an example. 1 and 1 is the input, and then the process would be addition, 1 plus 1, and then the output would be 2. Then binary code is just 1s and 0s, and computers interpret that and they turn it into images and letters and numbers and syllables and everything. And then we saw patterns in binary. We saw how it's so similar to our regular number system. Then we looked at binary light bulbs and how, we can represent 1 and 0 as on and off, and also yes and no, 1 as yes, 0 as no. Then we looked at numbers in binary, and we looked at how to represent numbers in binary. Then we looked at our ASCII chart, and that was American Standard Code for information interchange. And we just looked at how you can represent it in ASCII. Then we looked at letters in binary and how you would represent that. So I hope you guys liked this video, and thanks for watching. I hope you guys subscribe, like, and hit the notification button, and I hope you guys like this video a lot, and I hope a binary makes sense to you guys, because binary, we just take it for granted, but that's how our computers work, and it's such an amazing process how a computer takes just 1s and 0s and turns it into all of these magnificent things. So hope you guys enjoyed this video, and the thing you're watching right now has binary included in it. So, don't take binary for granted, because binary is awesome. So I hope you guys enjoyed this video. Don't forget to subscribe, and I'll see you guys later. Bye!